In this video, we are going to break down one of the most critical security concepts in modern applications, vertical access control. First, we briefly understand what vertical access control actually means. Then we will explore something very important, mass assignment, and how it can silently introduce serious security risks into your application. After that, I will show you a vertical access control vulnerability in our application. Not just a theory, but a practical demonstration in our project you can relate to. And finally, we will do a secure fix of critical vertical access control vulnerability in our system. Let's start with vertical access control. Vertical access control deal with access between users who have a different role or privileges. For example, a normal user can access regular features in an application, but admin-only functionalities or page must be restricted. If a normal user can access admin APIs or admin panels by exploiting some vulnerability in the system, that's a vertical access control failure. The main goal of vertical access control is to prevent privilege escalation, where a lower level privileged user try to perform actions that should only be allowed for higher level roles. Before moving on, let's understand what mass assignment vulnerability is that actually leads to vertical access control in our application. Mass assignment means the backend takes everything the user sends and save it directly in the database records without checking what should or should not be allowed to update. Imagine you are updating your profile using an API that is supposed to accept only fields like name and email. But instead of sending those fields, an attacker adds an extra field in the request, like role with value of admin, which should not be part of an update user information API. If the backend does not properly restrict which fields can be updated, it will accept this value and saves it. As a result, the attacker can change their role from normal user to an admin in its database records. And once that happens, the attacker can access admin level features and perform actions they were never supposed to have access to. Now let's see how this vulnerability exists in our system. I will provide the project link in video description so you can explore and test them on your own. First, we try to log in with an already registered user in our system. If the credentials are valid, the server returns a JWT token, which we then use to make requests as an authenticated user. You can see our request succeed and we get a JWT token. Let's copy this token and paste in our authorization headers. After doing so, request made from this tab goes with the JWT token to identify the user. Now let's call the API/user/me endpoint using a get request to get users its own profile information. This API returns the user own profile information including ID, name, email, and role. As you can see, the role is set to student value. But what if a normal user try to view all the registered user in our system? We can do this by calling the API/users endpoint with a getRequest method. Let's send this request, but we get an error saying only admin level privilege required. Since our current role is student, access is denied. Similarly, when we try to access all the enrollment records in the system, we receive the same error, admin level privileges required. But there is a vulnerability in our system that allows an attacker to change their role from student to admin, gaining access to admin-only functionalities. This issue exists in the Update User Profile API. Let's see what happens. This API is supposed to update user information like name and email. But what if we also include a roles field with the value of admin in this request? When we send the request with put method, the response shows the updated user data. The name is changed as expected, but the role field is also updated to admin from student. The user now has an admin value stored in his role field in the database records. This means our student user have now admin privileges and access all the restricted functionalities. Let's verify if we can access admin only functionalities from student account. But first, we need to log in again with the same student user credentials we did before and generate a new JWT token. We use that token to make further requests. You can see we are logging in again with the same email of student A. After a successful login request, we use this token in the authorization header and send a request to the API/users endpoint. This endpoint should only be accessible by admins, and now we can see it returns the full list of users in the system. That means our request is succeed. Let's send another admin-only request to fetch all the enrollment record. This time again the request succeeds and we receive all the data. The same APIs give us admin privilege required response instead of an actual record before. We change the user role to admin by exploiting the vulnerability, but after that we got access to all the users and enrollment information in the database. Let's check our profile again. We still have the same student email, but now our role is admin. This means we successfully exploited a vertical access control vulnerability in our system by changing our user role from student to admin and accessing admin functionalities using mass assignment. Let's understand what problem exists in our code. Here is the controller function responsible for updating user profile data. It receives the user input from the request body and stores it in the updates variable. Since the input comes in the JSON format, the code extracts all the fields and their values and directly uses them to build the SQL query. The problem is there is no validation or filtering of which fields are allowed to be put in the query. As a result, when attacker includes a role field with the value of admin in the request, the system blindly accepts it and updates the user role, leading to privilege escalation. So how do we fix this? We solve it by introducing an update profile DTO function. This function acts as a filter. When a request comes in, the JSON data is passed through this function, which only allows specific fields like name and email to be passed through. Now let's export and use this function in our update profile controller function. Now after this fix, if an attacker tries to include a role field with any value such as admin, the function simply ignores it. This approach or filter is called DTO, Data Transfer Object. It is commonly used in web applications to control and filter what data is allowed to pass to the API as an input. DTO can also be used to filter out response to the users. For example, when sending user profile data back to the front end, we can use a DTO to exclude sensitive fields like password from the response. So this method is very useful in preventing unauthorized data modification and protecting sensitive fields from being exposed or manipulated. Now our code is fixed. Let's verify if the issue is fixed. We log in again with another student user and obtain a new JWT token. After authentication, we use this token to send API request. First, we access the user own profile using API/user/me endpoint. This response shows the username as student B and the role as student. Next, we try to update the user information by sending request with a new email and also including a role field value set to admin. Let's see if this time we try to succeed in changing the user role to admin. Let's send the update request. We can see in this response the email is updated as expected, but the role value remains as student. This happens because update user DTO function ignores the role field and its value completely. The request is processed, but unauthorized fields are filtered out. Finally, we try accessing admin-only APIs like fetching all the users and enrollment records, but both requests return an error indicating that admin privileges are required. This confirms that vulnerability is fixed and vertical access control is now properly enforced in our system. In the upcoming videos, we will go through on more details of how to prevent vertical access control vulnerabilities in real-world applications. If you face any difficulty while setting up this project, feel free to contact me. I will try to help. If you found this video helpful, don't forget to like and subscribe to the channel for more content on application security.